Hello, everyone, and welcome back. Where we just wrapped up our unit on the internet, cybersecurity. It's a lot of information, but the fact that we wrapped it up means we're ready for a test. So, tomorrow will be test day. We'll open it up first thing in the morning. Effectively, you have until I believe it's Wednesday, 1 p.m. is currently what's on there. So you have that time to take the test. Note that as soon as you start taking the test, it's a 48-minute timer. And so you need to finish it basically in one sitting. But you do have a pretty big window where you can take that. Just be prepared to kind of sit down whenever you're actually ready and commit up to 48 minutes in order to take that. So today we'll be looking at some multiple choice questions because that's all the test is. No erroneous code on this one because we've been talking about internet cybersecurity, not programming. So let's get started, and we're going to kind of move through this. And if we got enough time, maybe I'll go through the slides, kind of all of them, and highlight important things. I don't know. I don't know how we're going to do on time. I would like to tackle this kind of one question at a time and give you a little bit of time in chat in order to respond. Sound good? Okay. Question number one: desktop computers, laptops, tablets. Go away. Desktop computers, tablets, smartphones, and other devices are made by different companies, yet they're able to access the internet. This has led to widespread use of the internet from many different kinds of devices. Which of the following makes this possible? Give you a couple of seconds in chat. This one's just kind of what allows us to all these different devices to communicate. Our answer here is going to be Charlie, the open standards and protocols. Okay. Alpha and delta are very similar, right? Fault tolerance refers to the internet's ability to tolerate fault. That is, something goes wrong, maybe a cable gets severed. It's not a big problem. Same thing with redundant routers. Having redundant ones means that if one goes down, it's just not a big deal. We can still route things around the internet. Those are relatively close to each other, and neither of them are the reason why all these other devices can communicate. Ultimately, Charlie is our answer. Bravo is dealing with domain names. For instance, this is on this Google Doc. The biggest domain here is com, followed by Google, then into docs, right? We call these subdomains here, but com is the biggest domain. And that's what that's talking about. There may be other domains such as org, etc. that is referring to, and that's not the reason why all these devices can communicate. Let's look at number two. A user enters a web address in a browser, and a request for a file is sent to a web server. Which of the following statements are true about how the file is sent to the user? Item 1, the file is broken down into several packets for transmission. Item 2, the packets must be reassembled by the user's device upon receipt. The user's browser must request each individual packet in order until all packets are received. Let me get some answers in chat. Our answer to 2 is indeed Bravo. Right. This is talking about just packets in general. What we call is packet switching. This is kind of the backbone of the internet and how it all works. Right. We take a file, we break it down into smaller packets that can be sent out. And what's kind of great about that is the packets don't necessarily have to go all the same route. Right. Keep in mind the internet is very redundant. There's multiple ways to get to a destination. But because the file is broken down into several different packets, they can take different routes in order to reach the destination. Maybe by the time one packet gets to a certain location, there's actually a faster route for subsequent packets, that sort of thing. And so we break it down into smaller packets before sending it out. Then at the other end, they are put back together. And the way that we're able to put these back together is that each packet has header information. Most importantly, a destination IP address, a source IP address, right? That's where it's going to, where it's coming from, and then an ID number, which tells the order of the packets and how they should be reassembled at the other end. Item 3 is just not true. The user's browser must request each individual packet. You just request a file, and before the file leaves the server, that's where it's broken down into packets, assigned header information, and then sent out. Bravo was our answer. Let's look at number 3. Each packet being routed around. Let's see if we can actually make this a little bit bigger. Each packet being routed around the internet contains header information about the packet itself. It also contains part of the file being transferred, which is known as the payload. Imagine that you are sending an image of a basketball player from computer A to computer B across the internet. Of the following, which information would be contained in each packet header? Select 2 answers. So we got to get 2 out of this. Alpha says the color of the upper left pixel of the image. This is in the header, question mark. Bravo, the IP address of the destination computer. Charlie says the sequence number of the packet in relation to all other packets of the image. And Delta says the name of the basketball player represented in the image. Let me get some answers in chat. Pick 2. Bravo and Charlie is correct. This is asking what is in the packet, or sorry, what is in the header of a packet. And I actually just answered that on the previous question. Most importantly, it's going to be destination IP, source IP, and then lastly, a sequence number, an ID number, so that we know the order to put these things back together, right? The file has to be reassembled once all the packets get to the destination. And that's what the ID number does. This is the type of information that you'll find in a header, whereas alpha and delta is relative to what's in the payload itself. The payload, keep in mind, is the actual file, right? If you're trying to get an audio file like an MP3, an image file such as this one is talking about here, or a video, that the actual data pertaining to the file is in the payload, where the metadata, stuff that's in the header, is important for transferring it around. Number 4, an IP version 4 address has 32 bits. In anticipation of having more devices on the internet than there are IP version 4 addresses, we are currently in the process of switching to IP version 6, which uses 128 bits. Which of the following best describes the result of going to 128 bits instead of 32 bits? Let me get an answer in chat. This one's a little bit harder. Our answer here is Bravo. Okay, we're working with, when we're talking about bits, bit is short for binary digit. So we're talking about binary. When we talk about 32 bits, we're talking 2 raised to the 32nd power. Let's zoom in here. Let's see how this looks. We're talking about 2 to the 32, right? I don't actually need to evaluate that. Here, we're talking about switching to 128 bits, or 2 raised to the 128. What we're most interested in is, what is the difference here? And mathematically, the difference is as simple as subtracting 32 from 128. And that's where we get the 96 from. The difference is 2 to the 96 power. We actually don't have to evaluate these out. Even if you plug these into a calculator, this is going to end up giving you scientific notation. So that math's a little bit hard. All we're really doing is subtracting the number of bits, but it is represented in terms of binary. That's what we're actually gaining. Which of the following is not a characteristic of the redundant nature of routing on the internet? Alpha says the existence of multiple paths between 2 addresses. Bravo, the ability to transmit data between 2 devices even when some connections in the network are broken. Charlie, the ability to reroute data when one connection is overloaded. And delta, the ability to use the naming system to avoid naming conflicts. Our answer here is indeed delta, right? When we're talking about redundant nature, this is also known as fault tolerance. Basically, aside from your house to the ISP, stuff that we call the edge, right? The stuff at the edge, there's only like one connection. There's only basically one line running from your place to the ISP. But from there, there's just multiple connections between all these different routers. And the idea is it's fault tolerant. If one of them messes up, if one of them's overloaded, it's not a big deal. There's multiple paths. So there's so many paths. That means that even if one gets broken or severed, that's not a problem because there's multiple ways to bounce it around. And then lastly, we can, like, it doesn't necessarily need to be severed or broken. It could just be super busy. Again, basically every time the packet hits a router, the router is going to ask, what is the fastest way to get you to your destination? And so it checks. Maybe it's checking at the moment. It finds that a line is severed, it is broken. Or maybe it checks and finds that some type of route is overloaded. Either way, it's going to look for what is the most efficient way to send that packet. All right, 6. Let's zoom out here. The figure below represents a network of physically linked computers labeled A through F. Computers with a line between them can communicate directly to each other, and if two computers do not have a line connecting them, they must go through at least one other computer to communicate with each other. For example, let's zoom out and down some. Information can be sent directly between computer B and E, but the information sent between computers B and C must go through the other computers. B and E can communicate directly because of this line. But for B and C to communicate, it has to basically route around, right? There is no direct line going from B to C, so in order for them to communicate, it's maybe got to go to E, D, and then C. Hopefully you're a little bit observant and you can recognize that the most efficient way, and what it would probably do unless A is busy, is route through A, because we can go from B to A to C. Okay. Here's the actual question. What is the minimum number of connections that must be broken or removed in the network before E can no longer communicate with B? Let me see if I can get both of these on the screen at the same time. So here's our image. What is the minimum number of connections that must be broken or removed in the network before E can no longer communicate with B? Help me out. I need some answers in chat. Okay. Where's the timer on the board? I'm keeping time up here. So it's almost like they're trying to kind of lead your thinking, but in the wrong direction. It says, how many must be broken in order for E to not communicate with B? Well, I feel like most people's natural inclination is to look at E and see the lines coming out of E. It's like, our answer here is actually bravo. The reason being, if we just cut these two lines that are running into B, B can't communicate with anything, including E. Our answer here was bravo. We can get rid of these two lines that are just coming out of B, and then B can't communicate with anything, including E, echo. It's not a trick. Number 7, let's zoom back in. What is the function of the domain name system, DNS? Alpha, to sell website names to web developers. Bravo, to assign a unique domain name to every computer. Charlie, to make sure that each IP address has only one corresponding domain name. Or Delta, to translate domain names into IP addresses. Let me get some answers in chat. I like the answers I'm seeing. This one's just vocabulary. Okay, our answer here is Delta, to translate domain names into IP addresses. First of all, what are we talking about? Well, here's Twitch chat. Here's all these incorrect answers. This is a domain name, right? But what it really corresponds with is an IP address. That is some type of computer, a server that is hosting this file, that's basically running this website. And so for us, it's hard for us to remember numbers, like a series of numbers, but it's significantly easier for us to remember text, to remember names. I'll give you another example. If I try to ping google.com, if I can learn to type, right? I typed in google.com. That's easy for me as a human to remember. But what's behind, what gets translated into, this looks like IP version 6, by the way, is an IP address, right? So whenever I'm trying to actually connect to Google, what I'm really doing is having my computer connect with another computer. Really, is requesting a file be sent back to me. So the only job that the DNS has is to basically keep a log of those things, to translate the domain names, the text that you enter into a web address, into IP addresses so your two computers can communicate. Right? These other things, there's basically organizations that kind of handle those. For instance, Alpha, something like GoDaddy, any other website or any other business that allows you to purchase a domain, that's kind of what they're doing. Bravo and Charlie, I believe, is ultimately the same organization. I can't think of what the organization is called, but there is a worldwide organization that this is essentially their job, is to make sure that only one IP address is associated with a domain name. Basically, they have a list of the domain names that are available. Yeah. Okay. Number 8, Caesar Cipher is an older and since outdated encryption technique used by Julius Caesar to hide messages he sent to his troops. Using Caesar Cipher, each letter in the alphabet is translated to a letter with some given offset from the original letter. Characters that are not A through Z remain as is. For example, if the message is "Hi, Zoe," and the offset is 2, the encrypted message would be JKBQG, since the letter J is 2 letters from H in the alphabet, so on and so forth. Notice that Z is the end of the alphabet and the offset is 2. The algorithm has to wrap back around to the beginning of the alphabet so that Z translates to B. All this is doing is explaining Caesar Cipher. Suppose that you want to encrypt the following message. Remain home. Doing a good job with that lately. Of the following, which would be a potentially encrypted message using Caesar Cipher? So we want to put remain home through Caesar Cipher, and we want to know which of these is valid. This is kind of a difficult question. I'm going to give you a good bit of time, but I would like to see some answers in chat. those you've answered, give me some logic on how you got there. Good. So the shift in Caesar is consistent across the entire alphabet. So some of the responses I got were, why don't we just take E, right, which appears twice, and then compare it to the stuff that we get down here in our answers, right? This slot should be E, and this slot should be E. And they should be the same letter. So based on just that alone, Alpha looks pretty good, but let's come back to that. Because if you look at Bravo, based on that exact same criteria, it looks good. Charlie looks good, but Delta does not. These should encrypt as the exact same thing. So from that logic, we can cross off Delta. Okay. Another kind of approach or technique is, let's look at letters that are adjacent in the alphabet itself. For instance, M and N just have a difference of 1. I and H just have a difference of 1. So we can kind of look at what's going on with these and again help narrow down our selection. Right? So M, this one should be M. And then N, this should be N. There's no way that those could encrypt as the exact same letter. They should have at least a difference of 1. They should only have a difference of 1, I should say. So I can actually mark off Bravo based off that tactic. If I look at Charlie, this should be M and this should be N. Okay, that actually makes some sense because M comes 1 before N. And if you look here, N comes 1 before O. What if we check H and I? Right? I should come 1 after H. Here I have an I. And then K. Does K come 1 after H-I? J-K, right? I remember the alphabet correctly, right? H-I-J-K. So the difference here is actually a difference of 2. And we can mark off Charlie. Ooh, I hope that worked out just right. Our answer is indeed Alpha. This one is possible. Let's look at number 9. Alice and Bob need to exchange some private data online. To do this, Alice creates an algorithm that will encrypt and decrypt data. They secretly meet, share the algorithm, then they each use the algorithm to encrypt their message and decrypt the other's message. What kind of encryption process is this? A, symmetric, B, public key encryption, C, a Vigenère cipher, or D, firewall software? I need some answers in chat. Let's go. Our answer is indeed Alpha. This is symmetric encryption, and all symmetric encryption is the same way that something is used to encrypt is the same way it's used to decrypt. Caesar Cipher is an example of that because effectively there's a key, and the key for Caesar Cipher is the shift amount. And so in order to encrypt something, we apply a shift amount. In order to decrypt it, we undo that exact same shift amount to handle that. So symmetric encryption was our answer here. Vigenère cipher is a type of symmetric encryption. Public key encryption is not symmetric, it's asymmetric. Yeah. And then firewall software has nothing to do with encryption. Which of the following scenarios would breach the security of a message encrypted with a public key? Alpha, if the encrypted message was intercepted by a third party. Bravo, if the holder of a private key forgot or destroyed the private key. Charlie, if a third party accessed the private key. Or Delta, if the public key was made known. Let me get some answers in chat. Our answer is Charlie. Okay, this is talking about public-private key encryption. And keep in mind, that is the encryption technique where we make a key pair. There's a public key, which can be made public. If someone wants to send you something, they would use your public key in order to encrypt it. Only you can decrypt it with your, don't want to hold up that finger, with your private key. Okay, so that key pair, basically, they can go either way, but you need both keys in order to encrypt and decrypt. And the whole idea behind encryption is that we don't care if third parties intercept the packets. It's a jumbled up mess that they can't read, right? There's something known as packet sniffing, where essentially you intercept packets, and it's easy for an ISP such as Comcast or AT&T to do that because the packets have to go through their routers anyway. But if the packet is encrypted, and most importantly, we're talking about the payload, because you can't encrypt the header information, we're talking about the contents of the packet, the payload. That is encrypted. It's a jumbled up mess. Even if they intercept it, even if they look at it, they don't know what it says. They don't know what's in the packet. Okay? That is the whole point of encryption. If the holder forgot the private key or the private keys and destroyed, that means that stuff that's encrypted with the public key, it's just forever encrypted. There's no way to decrypt it. And Delta, you want the public key to be known. That's how people can send you stuff, is if they have your public key. Number 11, which of the following do HTTPS and SSL procedures ensure? Select two answers. Alpha, that the identity of the server involved in an interaction can be trusted. Bravo, that every download will be free of viruses. Charlie, that any messages being sent are encrypted and thus secure. Or Delta, that passwords, credit card numbers, and any other private information will not be remembered by the website. Select two answers. Our answer here is Alpha and Charlie. Okay, so essentially SSL and its predecessor TLS, they're protocols and certificates to register your HTTPS website effectively. So the stuff that's being sent through this website, let me bring back the header information. The lock kind of shows it, and then we see our HTTPS there when we actually expand it. All this means is that data going between my computer and this Google server where this document is hosted is secure. It is encrypted. That's all it means. Okay, SSL is basically how it's like the protocols on what's required. Now through that, it's also like a certified website. So a lot of the websites you go to, they'll actually kind of show you something here indicating, like Facebook or Twitch, that it is the actual legitimate website. And that is also kind of processed through SSL and TLS. Let's look at some of our distractors on this question, like Bravo. Every download will be free of viruses. Again, all that HTTPS and SSL are doing is enforcing encryption. Okay, so you could have encrypted website, but the actual files that you're trying to transfer could still have viruses. Delta, passwords, credit cards, and other information are not remembered by the website. This is just a trust thing between you and the website. You gotta hope that they're not storing credit card numbers. Now, it's incredibly bad business practice, and usually, I mean, if a website were to do this, they tend to kind of go under pretty quickly because they get found out that they're storing that stuff or anything like that. Let's look at number 12. Which of the following activities poses the greatest personal cybersecurity risk? Alpha, entering your password to a login to a website encrypted over HTTPS. Bravo, emailing your bank account number to an online vendor to purchase a product from them. Charlie, providing your email address when taking an online survey. Or Delta, downloading a free text editor program on the internet. Our answer here is Bravo. Now, I usually get a lot of complaints about this question every year. It's a bit subjective. A lot of people narrow it down between Bravo and Delta, but there's nothing wrong with downloading a free text editor program on the internet. In fact, I would argue that most of the good ones are free. Right? They're open source, things like Sublime, Text Editor, or Notepad++. Those are great free text editors. Now, I think most people are like worried about like a virus of some sort is the possibility, but free doesn't mean bad. There's lots of free things. I'm using Open Broadcast software, for instance, right now, and that is an open source software, completely free. So Alpha says entering your password to log into a website encrypted with HTTPS. You want that. You want your packets to be encrypted so that in the event that they get intercepted, it's not a big deal. So that's not a problem at all. Charlie says providing email address when taking an online survey. I mean, your email address tends to be kind of a public thing anyway. How else do people send you emails? So just giving your email address doesn't compromise you in any way. So Bravo, I think this is kind of hinting at the possibility of a phish is one approach they could be going with. Right, emailing your bank account number to an online vendor to purchase a product from them. You don't really want to do that. And another slightly is something that we kind of glossed over is most email services these days are using HTTPS. But when we were talking about something with our application layers, that there used to be one called POP3, and there's another one that are email specific. The thing with those services is they're not encrypted. So there's two things that's kind of wrong with Bravo. It's possible you're using an email service that isn't using HTTPS. Now that's a little outdated because almost all of them are these days. But this could also be hinting at the idea of a phish. How do you know the person on the other end is ultimately trustworthy? Computer viruses come in many forms. Which of the following descriptions is most unlikely to be describing a virus? Alpha says it is attached to a program that runs each time the program is open. Bravo, it is disguised as an accounting program which runs when the program is open. Charlie, it is sent as an email that asks recipients for their credit card numbers. Delta, it is a piece of software that looks for security holes in a network and uses those holes to infect other computers. What's our answer to number 13? Of note, It says unlikely. Which of the following descriptions is most unlikely to be describing a virus? And our answer here is Charlie. Now, the easy way to answer this question is Charlie is very clearly phishing. It is sent as an email that asks recipients for the credit card numbers. That's not a virus. A virus is basically a bit of code, a program that does all these other things, right? It could be disguised as a program. It could run any other time another program runs. Most importantly, viruses tend to spread. That's kind of what distinguishes them from other malware, is that they try to spread to maybe other computers or other files. Number 14, which of the following are true statements about DDoS attacks? DDoS attacks compromise a target website by DDoS attacks compromise a target website by flooding it with requests from multiple systems. Item 2, DDoS attacks are carried out using a large group of computers. Item 3, DDoS attacks can be prevented using encryption. What's our answer to 14? Answer to 14 is Charlie. So a denial of service attack is when you attempt to bombard a website or another computer, another device with just data, with the whole purpose of either A, shutting it down, or B, just flooding it with so much that other things can't get in, right? It's possible that a server, a website, just has too much incoming traffic to handle all those other people. For instance, Amazon on Cyber Monday a couple of years ago had so many people coming in. It wasn't a true denial of service attack, but they were just flooded with too many people. The servers couldn't handle it. That is denial of service. The moment it becomes distributed is when multiple computers are involved. Okay? So 2 is basically that. DDoS attacks are carried out using a large group of computers. And item 1 says DDoS attacks compromise a target website by flooding it with requests from multiple systems. Yeah, you also see the multiple systems which separate it, that is, make it distributed and separate it from denial of service, but they are attempting to flood a website. And by me pinging Google, this is the most minor of DDoS attacks, but basically I'm sending 32 bytes of data to a Google server just over and over and over again. Imagine this on just like a large scale, and that's effectively a DDoS attack. At some point, the server, in this case Google, the computer, can't handle it. Now, it's hard for one person to do a DDoS attack because they're limited by their upload speed. So it tends to take multiple systems, that is a large group of computers, in order to be successful. 15. Which of the following are true statements about phishing attacks? Item 1. Phishing attacks are characterized by communication from one person trying to trick another person into divulging personal information. Item 2. Phishing attacks can be defended using the DNS system. Let me get some answers to 15 in chat. Our answer to 15 is alpha. Effectively, this is the definition of a phishing attack. It's one person trying to trick another person into divulging personal information. Item 2, phishing attacks can be defended against using the DNS system. The domain name system, all it does, as we saw from an earlier question, is translate a web address into an IP address. Now, there is something known as DNS spoofing. That is essentially where you somebody hacks into a DNS server, which is a computer that is responsible for actually enacting this. That is, it is a computer that has a copy of all the domain names and their associated IP addresses. DNS spoofing would mean a hacker breaks into that machine, that computer, and edits the ledger, the DNS ledger, so that maybe a different IP address is associated with the domain name. That's not phishing, though. That is DNS spoofing. Okay. This document, along with the answers, which are at the bottom, is going to be available on Canvas. I would review that. I would also look back through the slides. You don't have to do a deep dive on the slides. There's a lot of information, but like skimming would be one of the things that I would definitely do. Test tomorrow, but we're going to wrap up our stream, guys. Good luck.